Welcome everyone. Welcome back to the Routing Loop. I'm Matt Lewis, and we've got Tom Adamski here today. We've got a great session for you folks. So today we'll be talking about app networking, and we'll be specifically doing an introduction to Amazon VPC Lattice. So we're ending our Chalk Talk series, or reinvent recaps, I guess you could call them. We really feel that Chalk Talks are one of the most important sessions at reInvent, because you get to interact with specialists like Tom and myself. So we tried to recreate that with our last couple of sessions on the Routing Loop, and I think, Tom, it's been a great success. We had some really good sessions. I think we did observability last week. What else did we have in the Chalk Talk sessions?
That was so popular. We
There was
had
a whole bunch.
firewalls within AWS. We had bringing your own IP space into AWS. There was a whole set of really good sessions. They're all available on demand, so we do track them on the Routing Loop page. So if you want to catch up on the sessions that you've missed, pop up to our Routing Loop. It's the routingloop.net, and then all the past sessions are recorded. You'll notice as well that today we're streaming purely to Twitch. We used to stream to different platforms. We kind of keep changing things every quarter. We'll try and solidify it better for you guys and make sure that we can stream to like solid destinations that we keep. But Twitch is our kind of standard go-to. So today's sessions and most sessions of this quarter are going to be on Twitch.
So we've got some exciting sessions up and coming, and I don't know if we've updated the routingloop.net page yet, but we're doing a series on app networking. So there'll be a couple of sessions here. Today's the intro, which I think this is arguably the most important one, Tom, so no pressure. After our app networking series, we're probably going to do a connectivity series. So we get a lot of questions when we talk to customers and talk to you folks around how do you connect things in AWS. It's always a clear underpinning theme across networking, obviously networking and connectivity. So yeah, that should be exciting. But Dominic, welcome back. Yes, 2 sessions in a row now. So we'll see. I don't think I'm up next week though. Tom, you might be. I'm not sure. I haven't checked the schedule.
Yeah, I think I'm the host next week, so we're doing a little bit of a rotation. So presenter one day, the host the other. Um, you know, always a bridesmaid's, never a bride, but this time I'm a bride.
Nice. That must be a Polish saying. I've never heard that one.
No, that's an American saying. No, I think that's
American?
American.
Okay.
Yeah,
Oh, you
yeah.
forget I'm not American, but well, should we get in there? I think you've got a bit of content to share with us, right? Should we
Yeah,
throw that up on the stage?
yeah. Let's
Oh, we both clicked the button.
cool. Right, so we got an hour, so I'm gonna jump straight to it. This is the first episode of the series, and we'll go through kind of comparison of different options that we have today, a very high-level view, and then we'll just start looking at all of the building blocks, ultimately of Amazon VPC Lattice, which is the main building block of what we call application networking. But we will touch on some of the other options as well. But in majority of cases, VPC Lattice is probably the solution you might be deploying for your application-to-application connectivity use cases. So before we dive into Lattice, I want to do a little quick comparison. What do we mean by application networking, and how does it compare to like the traditional network-to-network connectivity you might be familiar with? So in this example here, we have client VPCs on the left and then application VPCs on the right, hosting some kind of application, maybe a database. And in the network-to-network connectivity, we ultimately have a networking pipe. And we'll talk about what that pipe could be. But you're creating a path from client VPC to the app VPC somehow through using things like routing. So you'd have to configure routes, update your routing, send traffic through whatever kind of connectivity you created, and then that client can consume the applications and databases. With the application networking, the model is slightly different. We're bringing in the applications and the application VPCs and logically presenting them to the client VPC such that it looks like the client connects to something locally in their own VPC. And ultimately, behind the scenes, we can transport that traffic to the backend applications, databases, resources, potentially things even on-premise. So when we overlay these models with some of the services that support them, for traditional connectivity, you would be using things like Transit Gateway, the in-region logical router, Cloud One, which is ultimately a set of managed transit gateways managed through a centralized policy. So AWS is managing a lot more components there, and you deploys those components globally, not just in a region. And then VPC peering, which is, I think, are the oldest connectivity mechanism between VPCs. Now, if we're talking about application networking constructs, we will have Amazon VPC Lattice, which we spent most of the time on today, and Private Link. So Private Link also, in a way, is going to be used with VPC Lattice. We'll show you the integrations there. But those are the two main building blocks of the application networking connectivity constructs. And you might say, oh, but is API gateway, why is not listed here? Because API gateway also would be using private link to expose its endpoints to access the API. So a lot of the services out there might be using one of those two constructs to expose themselves to the clients. So at a very high level, so I'm going to start with like a 10,000 feet view on VPC Lattice, and then we'll start breaking it up into pieces and talking about each building block. But at a very high level, a VPC Lattice has a construct called the service network. And then that is the thing that will be facilitating communication between the client VPCs and then app VPCs. And the service network in Lattice can allow you to transport TCP between the client and the applications. And for that, it will act kind of like a NATing solution. So when I presented this to a customer before, they said, oh, so it can just do VPC to VPC NATing for a specific TCP application. And kind of that was a really nice way to describe it. And that's exactly what it can do. And at the same time, it can act as a proxy for HTTP, HTTPS applications, or for TLS pass-through. So it's got those two modes where you're even sharing or accessing any TCP application, or you're proxying HTTP applications. And it's not just one client to one application VPC. You can keep adding application VPCs, and you can keep adding client VPCs, and have Lattice Service Network become the connectivity construct between all of these environments. So you don't need to have a transit gateway. You don't need to have answers. Lattice can help facilitate that communication without any of the other components.
Do you think there's a or here, so a transit gateway or VPC Lattice, or do you think it's more of an and where you might have multiple?
I think it's a good question. It's likely going to be an and, right? Because you could have scenarios where all of your applications can be exposed through VPC Lattice, and then it could be an or. But realistically, especially customers that today have transit gateways, have Cloud One deployed, already have the network connectivity established, for them it would often be an or. So there would be kind of these specific use cases where VPC Lattice could be a really good fit, and that could be running in parallel to the already established traditional networking connectivity. I think Jamie, I don't know if it's next week or in 2 weeks, we'll do a session specifically on those use cases and talk about where VPC Lattice is really solving the problem. So even if you have already traditional connectivity established, it still makes sense to look at VPC Lattice for those use cases. If you're going greenfield, I guess then it's a bigger decision, right? Which direction you want to go, and then it could be either or it could be a little bit of both. But if you're brownfield already established with Transit Gateway, it will definitely be an end. So you will be using both in parallel.
I think maybe this is a leading question because you might be covering this, but Dominic's asking if we can use VPC Lattice without standard networking, route tables, ACL, security groups. Like what disappears or what doesn't apply anymore now when you start using VPC Lattice?
Yeah, I think I can touch on it right now, but it'll probably become more transparent as we go through the content. The thing you don't have to care about is routing. So all of these VPCs here could have overlapping address space, but because you're making it look as if the application on the right-hand side appears in the client VPC with a local IP address, the client thinks it's talking from an IP point of view to a local IP address. There is no need to really deal with complicated routing. There's a scenario where you still routes need to be populated. I'll show you the example. But in general, you're removing the requirements to really deal with routing. So where we see a lot of value is teams or developers who really just want to develop applications, deploy those applications, and not really deal with, oh, I need to create a load balancer, and then I need to make sure that this load balancer is in a VPC that can be reached by wherever my clients are. All you have to do here is just create your application, register it with Lattice, and then it will automatically appear in the list of applications that can be accessed through Lattice. And then the clients, as long as they have the DNS name for that service or application, they'll be able to connect. Yep, well, it'll become more transparent as we go. And I kind of just realized that my drawing looks a little bit like a rabbit with wings. If you look at it sideways.
I was thinking it looked like some kind of camel with the head and the hump and well, I guess 3 legs or
Yeah.
3 sets of a caterpillar maybe.
Yeah, depends on which way you look at it. Yeah, it's like one of those
Oh yeah,
Ross judge
I
tests.
see. Yeah. It depends on which direction you're looking. It does look like a rabbit with wings, actually. Yeah. In Tech First, good to see you again. Can we inspect traffic going through VPC Lattice if we plan to replace TGW with Lattice? I think that's a pretty common architecture that I think you've done a couple of sessions on this architecture where we've got transit gateway and an inspection VPC, right?
Yeah, it's a very common architecture. I think the big question, and we'll probably dive into this more in the use cases session, but some of the need to do inspection goes away. So, and it depends what you're doing on your firewall. So, if you're using a firewall with Transit Gateway to not really do inspection, but do more like access control, right? So you put this firewall in the middle, and ultimately all you're doing on it is saying, I'm allowing this IP address range to talk to this IP address range on this port, but you're not really doing a lot more on it. Then it's more of an access control function than really a true inspection function. And Lattice brings you this access control out of the box, right? Because you're only exposing the things that should be accessed and only to the VPCs and clients that should be accessing them. And then we can talk about some of the additional security layers you can add on top. But out of the gate, you're already only exposing the specific ports that you want to access. So having extra access control tool on top that says, I know, I'm only allowing these ports from this subnet kind of becomes redundant. But if you are doing some deeper packet inspection, I don't know, data loss prevention or some kind of web application firewalling, if it's a web application, that currently is not supported on Lattice. So if those kind of functions might still stay on the firewall, but yeah, keep giving us feedback and we'll listen to you if you need these things
I was
added.
going to say that sounds like a really good feature request, some kind of native integration with network firewall and VPC Lattice service networks. That would be pretty cool.
Yep.
All right, one more here, then maybe we'll keep going. Any concerns with the pattern where application consumers provision their own VPC Lattice service networks and service providers share their Lattice service with the service network? So I think this is really around ownership, right?
Yeah.
Who
So
owns different components?
you can cut it however you want. I have a slide on the account ownership and sharing, and then actually touching on costs and how these costs are applied to different accounts. But you can really divide it however you want. So you can have applications shared with the service network. You can have the service network shared with the clients. So you can share pretty much every single component in this scenario, and you can cut it however you want. I've seen independent software vendors actually like the ability to have their customers who might have a database expose the database to a service network that they manage, and then share the whole thing, and maybe multiple databases, multiple applications, share that with an independent software vendor that needs to analyze the data that you're exposing to them. So really, really flexible on how you're sharing and subdividing this.
I think Jamie's session is next week on use cases, so maybe there's a couple of examples there that we can pull from.
Yeah, we'll touch on specific examples of where this really works. But for the sake of the session today, the way we're going to divide the topics is we'll talk about the consumer side and the provider side. So when I'm saying provider side is the things that you're sharing with Amazon VPC Lattice, the applications databases. And then consumer side is the locations from where you're consuming things that were already shared. I'm showing it as a very clear divide here, but ultimately the same VPC could host applications that are exposed to Lattice, and the same VPC could also be the consumer. But it's going to be easier to from a learning point of view to look at them as on the left hand side we will always have consumers, on the right hand side we will have providers.
And I think you said earlier that Lattice is basically consuming or using IPs inside the consumer VPC. Is that right?
Depends on how you integrate it. We'll talk about those options because there are differences in terms of IP usage, what IP is. I have a life of a packet, so exactly what IP address you're going to have at which stage of the forwarding for VPC Lattice.
All right.
Now, the important bit is that we have this concept of services and resources. So when we say services and resources, either for consumption or sharing, we mean very specific things because they're two different things that you'd be accessing. So we can do a quick comparison to level set what is a service, what is a resource when we're talking about it. So a service from a protocol perspective is going to be your HTTP, HTTPS application or your TLS pass-through application. So you can think about services kind of like mini application load balancers, very, very, very similar. Whereas a resource is going to be anything that has TCP. So the protocol we're going to be using here is TCP. So it's probably closer to something like a network load balancer, but it's not really doing any load balancing. So from a forwarding logic, services do load balancing. So if you're getting traffic through Lattice to a service, Lattice will do load balancing for you to the destination. Whereas resources, what Lattice is doing is ultimately NATing the traffic and then forwarding to the destination on the port that was originally hit. And I'll show you some examples. And finally,
and resources is pretty new, right? I mean, that was what, reInvent? Just as
correct. Yeah, we launched end of last year. So previously you could only do HTTP applications, and with resources we opened it up so you can do TCP, any TCP, and there's some very interesting integrations because when what you're targeting with a service can live on an EC2, EKS, ECS, Lambda, ELB. So pretty much any type of compute you can imagine running on AWS, you can integrate with Lattice. With resources, it's less about the compute. It's more about either the IP address that you're forwarding to or a DNS name. So that's the first service that we have in the networking space that can do a DNS lookup and send traffic to a particular destination after it's done that DNS lookup. And then there's a way to share specific AWS services, but today it's just RDS. We're working on adding more. Give us feedback on which ones you would like to see, but RDS is the first one, or relational database service is the first one where you can natively expose the RDS service running in your VPC through Lattice to another VPC.
Good question from Tech First here on the resources side. Can a resource see the original IP of a client, like NLBPP v2?
I have that slide. That's a really good question. We'll park
We'll
it.
get to that Tech
We'll
First.
get to it. Yeah, but it's a really good question.
TechFueled also says EFS also, please. I'm sure it's on a list somewhere, but we don't talk about NDA stuff here.
Yeah, interesting. EFS is an interesting one because it's such a large volume of data, right? It's a storage thing. So in those scenarios, you may want to just attach EFS through its own endpoint to wherever VPC needs to consume it. So that might be a different story. Might not be the ideal use case for Lattice today, but it's interesting. Okay, so let's talk about the provider side. So let's talk about registering services first. We'll talk about resources next, and then we'll talk about how you consume all these. So services, I really like using examples. So I have in my slides usually very little text and a lot of examples. So we'll use examples as the way to learn. So here we have all of the compute types. So we have EC2 instances, EKS, ECS, and Lambda, and we'll register these as different services with our Lattice service network. So the first thing we define, and by the way, we'll have a demo, I think in 2 weeks time. So we'll show you exactly, how it's done. So I'm not going to cover anything about, what you need to do in the console or what APIs to call, but I'm going to explain a construct. So you create the service definition, and the service can have one or more target groups. So for service one, we'll actually have two target groups. The first one is going to be EC2 instances. The second one is going to use Kubernetes. And maybe what we want to do is we're migrating from the EC2 instances to Kubernetes. So we're doing some modernization here. And the way the target groups work is they will automatically track as these resources are changing. So if the EC2 instances are in auto-scaling group and there's more added, just like a load balancer can, Lattice will be able to track these changes and make sure that it's load balancing to all of the active and healthy targets. Same goes for Kubernetes. For Kubernetes, we actually have very deep integrations. I'm not going to cover them in this session. I think we had sessions in the past where we talked a lot about it. there's a native Kubernetes API, gateway API that you can use to control Lattice from the Kubernetes side. So you don't even have to use AWS APIs. You can, in Kubernetes, say, I want to create a service. It needs to be Lattice. And here's my application inside Kubernetes. And again, Lattice is going to track all of the pods, all of the things that are representing that service in Kubernetes. You then register the service as a service association with the service network, and you're pretty much done. So a second example, service 2, we have a single target group. That's ECS. Again, if tasks within ECS are changing, Lattice is going to be able to track it for you. So you don't need to worry about like whack-a-mole with specific IP addresses. And finally, you can even register Lambda. So one of the target groups could be a Lambda. That could be its own service, or that could be a service you migrate to, right? If you want to move from EC2 to serverless, very easy to do. If we zoom in on one of the services to look closer on the anatomy of what's going on, every service is going to have a listener. So in our example, it's a HTTPS listener. With HTTPS, you will bring your own certificate, you will do TLS termination, but you can also do TLS pass-through if you want. Both options are supported. A client sends a request from their own IP address to the service. Then we have the routing. Similar to application load balancer, we can do routing based on the path, the header, the method. So we can say, if there's a specific host header, forward it, or specific header or specific path in the request, send it to a particular destination. Maybe here we just want to do all traffic going to both target groups, so we can set up weights. So we're saying 80% goes to target group 1, 20% target group 2, and then we load balance across, but taking those weights into consideration. And again, maybe we're migrating to Kubernetes, and eventually we're going to get rid of the EC2 instances. And then the request, as they're coming in for Lattice, they're going to come from the IP address range of the Lattice service network. And we're going to talk about in a second what that is. So those were services. Moving on to resources. So exposing something that is TCP, not necessarily even a HTTP application, but you also want to access that through Lattice. So in our example here, we have a service network, we have the VPC. Now, Lattice cannot talk to TCP things directly. You will always need to deploy a resource gateway inside your VPC. The resource gateway is going to grab a set of IP addresses from your application VPCs and then use that as a source. And then we will have different examples of resource types or resource configuration types that we can create and make accessible for Lattice. The first example is going to be a couple of EC2 instances, a few EC2 instances listening on a set of ports. We'll have an RDS database, and then we'll also have something on premise or maybe a specific server that we want to get to. And then we need to make sure we connect that VPC back to the data center using something like Direct Connect or VPN. So we need some kind of traditional connectivity there to get to our server on premise. Now, the way we define these, now for the first one, we can use the DNS-based option. So rather than specifying individual IPs for the EC2 instances, if there's a currently publicly resolvable host name that we can use, so app.example.com, that host name can be resolved on the fly, and then we can target all of the IP addresses that get returned back after the resolution. And then once we define the resource configuration, we can associate that resource through the resource gateway with our service network. Again, all these associations ultimately make the service network aware that these things exist, and now they need to be accessible by the clients. And in a second, we'll get into the section on how the clients are actually able to consume those. The other type of resource configuration is IP-based. So we're ultimately explicitly defining an IP address that we're trying to get to. That could be an IPv4 or an IPv6 address. If it's IPv6, it can be on-premise. With IPv6, it has to be something in your VPC. But if it's v4, it can be something that lives outside of your VPC.
Tom, question from Tech First. Just back on DNS, does it have to be public DNS?
Today, yes. We did get feedback that customers are asking to have a private DNS option. And we can't talk about roadmap, but it is something that we hear a lot from customers. So you can imagine we're taking that into consideration. Today, if you're setting up today, that has to be public DNS. So in this app.example.com, I would have to have a list of all my private EC2 instances or IP addresses. and then they get resolved on the fly and assigned for the traffic coming in through the resource gateway.
I mean, they're all private RFC 1918 A records anyway, right? So
Yeah.
it's not like anyone can reach them or do anything with them, but someone could look at this DNS entry and look at and see the A records
Yeah.
there, like a 10.0.1.15 or something.
Yeah. I think part of it is also you're having to mess with your public domain, right, to register these EC2 instances. And maybe it would have been much nicer to have a private hosted zone where, only privately appexample.com in that VPC resolves to those private IPs, but publicly, appexample.com is some public load balancer or something. So right now you can't create that split view. You have to go into your public domain, edit your public domain with those private IPs. Okay, and the final type of resource configuration is effectively an ARN, an Amazon resource name. Today, we only support RDS. So it allows you to, if you create an RDS database in your VPC, you can register that directly with a service network. So zooming in a little bit closer, I'm going to show you an example of how kind of this resource association works. Every single resource gets a unique IP address associated with it, and that's how it's identified. The ports that you decide to expose on the resource, so the range 2715 to 2730, that is also exposed on that IP address. So when a client connects to 2720, which is one of the ports we exposed from their own IP address, we then have the routing logic. So because this is TCP, we can't look in the application layer. We don't even know if this is HTTP application or not. So from a routing perspective, what we're ultimately doing is the resource gateway will do a DNS lookup on that appexample.com and get IP addresses that are under that name, right? If it's 5 IP addresses, it will take all 5, and then it will start assigning them randomly to different flows. So flow 1 gets IP address 1, flow 2 gets IP address 4, and so on. Ultimately, at scale, it's kind of similar to random load balancing. And then every time to live over DNS query, so if the appexample.com has a 60-second TTL, every 60 seconds, the resource gateway is going to do a lookup to see, has the IP addresses changed? Maybe something got removed, something got updated. And then it's the resource gateway with its own IP address connecting to the backend EC2 instances. And I have an even deeper slide showing you exact IP addresses of what's going on in each stage, but this is just to give you a highlight that it's the resource gateway doing the connection. That's something I already mentioned. There's going to be a little tips every now and then, but that is about how the resource gateway deals with DNS. So does it look up every TTL period? And then if multiple answers are returned, it just randomly assigns them to different TCP flows. Cool. That was the provider side. So that we registered some services, we registered some resources. Now we need to figure out how we consume them. So we're moving on.
Service Network Association sounds like some kind of club I can join.
Yeah, you wait until you see the domain names. Like we really like keeping the long names. So Service Network Resource Association. Yeah, it's
Like
definitely.
I can get a bumper sticker or something that I can put on my car.
I don't know if this sounds like an exciting club to join, to be honest. Resource Association. Okay, so there's two ways really on how you can get to a service network, and the first one I want to talk about is just Service Network Association. That's another association. This time you're associating the service network to a VPC. So it's not associating a service or a resource to the service network, it's associating the service network to a VPC. A lot of associations here. It's similar in way it's connecting to the VPC as an IGW or a VGW or a S3 gateway endpoint would, where it's not really burning IP addresses from your VPC, but it's creating this logical association when now this VPC is going to be able to consume services and resources that were registered with that service network. Now, the way you get to them is using DNS. And when you create services, every single service gets a unique DNS name, auto-generated DNS name, like here, service one, some ID, VPC Lattice service, and so on. And then there would be IP addresses associated with the service. So you'll notice that we're using 169.254.171 range. That's a link local IP address. and then unique local addressing for v6. So these are local IP addresses used for local networks. That 169 range can't really route outside of the VPC. And then another service would have another unique name. And you'll notice that it could use the same IP addresses, because with services, they're TLS or HTTP, we can share the same IP address and then define or figure out which thing you're trying to connect to based on the host header or SNI. So services will have can have the same IP address. Sometimes they'll have different IP addresses, but that really doesn't matter. We're distinguishing them when clients connect based on the host header or based on the SNI. Resource associations, on the other hand, ultimately resources, they each get a unique v4 and v6 IP address. In this example, .10 and .11, the v4 is in the 129.224 range. Yeah, that's how we distinguish resources, because resources might not be HTTP. They can be, but they don't have to be. So all we see is TCP connection. So we have to have unique IP addresses for each one to be able to know, okay, you're going to resource one or service network resource association one, which ultimately means resource one. So you'll see that the unique different IP addresses for each resource.
Good question from Tech First here on the client side. Does the DNS name matter?
The DNS name matters. DNS name is what allows you to connect to the right thing. So those DNS names is your service discovery. Absolutely critical to know what those DNS names are. Again, they're auto-generated. They look pretty messy, right? They're long. You can use custom DNS. I'll show you in a second how it's done for a service, but by default, just like when you create an application load balancer or a network load balancer, we auto-generate a host name for it. That's going to be a very long string. Some customers use it, but most customers usually would use custom DNS. Now, because we're using these ranges 169, 129, and FD00 for v6, that's one place where we have to update route tables, right? We need to make sure that the client VPC knows how to get to these 169 ranges. So whenever you create the service network association, the VPC route tables of the client VPC would automatically be updated to say, I know that 169.254 and 129.224, that is VPC Lattice. You don't even have to go in and call those APIs. That's done automatically. So for a client to consume a service, they do a DNS lookup. Service 1, 1D2, that is a public domain. So I can look that up from home and I will get back 169.254, 171.33, or 66. All right, so after the DNS lookup, I get an IP address. VPC Lattice will actually return local answer. So if I'm in AZ1, I will get an answer for AZ1, which is the .33. And then I will establish a connection to whatever is the listener on that service. So if it's 443, I just establish a connection to the service 443, and then I get sent back to whatever I registered as my services. So in, I think, service 1, that was like an EC2 instance, in auto-scaling groups, and EKS. We talked about the tip. So each service can share the same IP, but resources, they always have a unique IP address for you to be able to get to them. Okay, so if you want to do custom DNS, so maybe I don't want to have my clients use the really long name. Whenever I create a service, I can create it with a custom domain name. Here it would be service1.example.com. Well, whenever I register, if it's a TLS or a HTTPS-based service, HTTPS-based service, I have to bring in my own certificate. So I would use ACM to bring the correct certificate for my domain that I want to use. And then I have to specify at service creation that I want to use a custom domain name. I don't want to use the service 1, 1D2. And then I have to update DNS. So I can do that in a public DNS zone. So if I own service1example.com, I can go into it and publicly change that to CNAME to translate to service1, 1D2, the long name. I can also create a private DNS name specifically for my client VPC so that it resolves, service1.example.com resolves to Lattice only locally in the VPC. It's up to me, right? So if I use Route 53 for the DNS resolution, I can also not use a CNAME, I can use an alias record. It's just a different type of record. But ultimately, I have to create this mapping between in DNS between the custom domain I want to use and the the auto-generated hostname. So when the client does a DNS lookup for service one example, they get back the same IP addresses that are registered with the service, and then they establish a connection. And because we configured Lattice service one and defined what the expected domain name is going to be, we'll now know what to do with this traffic, where to forward it, and so on. Now, if you're using private hosted zones, a tip here could be to use resolver profiles for simplifying how you are distributing those private hosted zones across different VPCs. So private hosted zones are private domains. In those private domains, you would have that mapping, service1example.com equals, the long name. If you have, hundreds of VPCs, create a profile, share that profile with all those VPCs so they can associate that same domain.
On the side, I'm looking up all your DNS names here, and I'm not getting any hits, Tom.
Oh, because they're made up. You're not going to get any hits. They're actually.
I'm just checking.
they're actually longer. I think I had to shorten them to fit them on the slides.
Yeah.
So nice try, though. I was wondering if someone's going to do it.
I figured I'd do it and see if anything came back, but
yeah.
No bueno.
Okay, so let's talk about the association. It's where it kind of falls short a little bit. So um, here we have a VPC connected to service network A, and maybe you have another VPC connected to service network B, and that has resource association too. Now, if we want the second client VPC to give access to service association 1 or to service 1, we can't connect the single VPC, or we can't associate the single VPC with two service network. It's a one-to-one mapping. Right, so if I'm now a client in the VPC at the bottom and I want to talk to service network or service 1 that is associated with service network A, I can't. I have to bring in the service to the service network I'm already associated with. So something to be aware of, it's a one-to-one relationship. A single VPC can't have multiple service network associations. Yeah, but if I can move the service network, I can move the service, sorry, between different service network and associate it with multiple service networks at the same time, so that both clients can now talk to service one. Now, when we look at this on-premise, so say we have a VPC that we want to connect from on-premise, the DNS lookup will work. So I can do a DNS lookup, I will get the 169 address. I can't get to service network A because this is not a routable address space. Same thing applies if I'm trying to get to it from another VPC through Transit Gateway, peering Cloud One. DNS will work, but I won't be able to connect. Just a reminder on the tip that this just doesn't work. So the solution for that is a different type of connection to a service network, which is a service network endpoint. Under the hood, this is powered by Private Link. So it's like using Private Link to connect to a service network. All right, and we'll have an example of how that looks like. So we stretch the client VPC because now we can have one client VPC, and we can have an endpoint for service network A, and then we can have an endpoint for service network B in the same client VPC. So the client can talk to both service network through the endpoint. So we're removing that limitation of association was one-to-one. Endpoint is you can have multiple endpoints to multiple service networks. Before we go into connectivity, let's zoom in on how DNS changes, because as soon as you do an endpoint, the DNS resolution gets updated and you need to use different DNS to be able to connect to the same service and to the same resource that you were connecting to before for the association. So when the endpoint is created, we will automatically create new auto-generated host names for each service and each resource in that service network. So service one now gets a new name that is a combination of the endpoint ID and the service network service association, SNSA, representing service one. And the IP addresses that are returned behind that host name are IP addresses that are hosted on the endpoint. So you can see 10.0.0.10, that is part of the client VPC CIDR range. So this is now an IP address that is going to be used to connect to service one, but it lives on the endpoint, and you can connect to it locally from a VPC. So we're no longer using, with the endpoint model, we're no longer using the link local IP address space. We're actually grabbing IP space from the VPC range. For resources, same story. Each resource gets its own unique name, again, a combination of the endpoint ID and this time Service Network Resource Association, and a unique IP address on a resource by resource basis that can be used to consume the resources. So client does a DNS lookup if they want to talk to service 1. If they use the new name, the new auto-generated host name, they get back, say, 10.0.0.10, and that's what they will establish the connection to. If they hit 10.0.0.10, that is going to be the endpoint inside of VPC, and that endpoint is going to pass the traffic to service 1. Okay. So every single time there's a new endpoint, a new set of host names is created. So there's going to be a lot of host names. If you have like 20 services, 20 resources, you're going to have 40 new host names when you create an endpoint for your service network. So let's talk about additional benefit here. So we talked about that now with the endpoint model, you can have multiple service networks accessible from the same VPC, but with that you can and you can kind of connect to the service, but you can also now connect from other destinations. So from on-premise, I can do a DNS lookup on the host name that is associated with the endpoint that represents service 1. I get back the IP address that's part of the client VPC, and as long as I have a route to that VPC over the VPN, I can get to that service. Same thing goes for if the client is in another VPC, maybe connecting through, again, Transit Gateway appearing Cloud One. As long as they use the VPC endpoint 123 host name for service 1, they get to service 1. Now, they could also get to service 1 by changing the hostname ID and then connecting to the other endpoint and the other service network. And just like with connecting association, you can also do custom DNS and you can use your own domain names. But I'm showing you purely the auto-generated host names that are used here. But for all of those host names, you can replace them with your favorites or your preferred host name, custom host name, so you don't have to deal with the auto-generated long name.
Thank you. Yes, please.
Yeah.
Those auto-generated ones can get a little while. Try to remember them.
Yeah, there's no way to remember them. There's like a lot of dashes, and I've also shortened the IDs. I think the IDs are like 7 digits, so they won't even fit in the in the deck. So this is a heavily simplified view of how it looks like, but it's good to know that for every endpoint you have a new unique host name representing every single service, every single resource. And it's a combination of the VPC endpoint ID and the service network resource association or service network service association, which ultimately in normal speak means it's going to be a service or a resource you're trying to get to. Okay. So we can talk about security. So those were kind of the ways you present your resources and services as well as consume your resources and services. So now how do you control access between these environments? So we'll show you kind of a scenario where we have a service network connected to the VPC over association as well as an endpoint. And then we have a single service and a single resource registered with the service network. And then what do we do from a security perspective? So before we even start talking about like using security groups, the model immediately limits access by default, right? So previously, if you opened up a network between the client VPC and the app VPC, then you had to start adding controls to limit that access to say, oh, I only want to allow access to port 443, not all the ports on my EC2 instances. With the Lattice model, that happens automatically, right? The only thing that you're exposing is the service, and the service already only listens on port 443. So if you try to connect to the same thing on port 22, your traffic is just going to get dropped. On top of that, you can also use security groups. So if the client is part of some security group 1, there will be a security group around the service network VPC association, where you can control the inbound traffic. And for example, you can say that you only want to allow traffic from security group 1 or security group of the client, and then a set of ports that you're allowing access to. So 443, and then the range of ports to access the resource. So 2715 to 2730.
So this is a call back to Dominic's question before. There's still security groups
Yep.
and they're still used with VPC Lattice.
Yep, they're still used.
Route tables 2 inside the VPC, but really you're not really routing to the 169 address, right? I mean, you don't have to configure any routing for that.
Yeah, there's only routing is done automatically for that network association, because you need to know how to get to this 169.254 range that we're using on the service network. But if you're using an endpoint, there's zero routing. The endpoint is already part of your VPC address space, and you can get to it without any additional routing config. So yeah,
Can I override or break things if I start configuring 169 ranges inside the route table of the VPC? Do you think that would? I don't think it would override anything, right? It would
yeah,
still.
I don't know if it will let you even create a route for 169.254. I've never tried. I would have to check it to see if I can even break it, because I'm not sure if
Well,
it would let me.
so we've volunteered Alex, who is out right now, to do the deep dive demo session in 2 weeks' time. So we'll save that question for when she's doing the demo and say, hey, let's try and configure her out. I'll write that
Perfect.
one down.
Yeah, we'll see. We'll see
Cool.
what happens. Okay, so you have security groups on the client side. You also have security groups on the application side. So up top, we have a service, and your things, your EC2 instances, Kubernetes clusters, they will have their own security group. So the thing to remember there, that you need to allow traffic from the Lattice prefixes. So the traffic coming in, and I'll show you again, I have a slide literally in a second showing exactly the IP space, but you need to allow traffic from Lattice prefixes, and those are the same prefixes that are used for services and resources. So the 169.254, those are going to be source IP addresses getting to your application. So you need to make sure that this is allowed to communicate with your EC2 instances and EKS. That's one of the bigger issues I've seen with customers setting it up, is not realizing the need to update those security groups. And then for resources, everything comes through a resource gateway. So whatever security group you have on that resource gateway, that's going to be the kind of originator of the traffic. So for your actual application, so the EC2 instances, you would have a security group that you allow traffic from the security group that's around the resource gateway, so that the resource gateway can connect to the 2715 ports, 2730, and so on.
I feel like the security group thing is one of the first questions I'm thinking, like IT crowd style. Like, did you check the security group?
Yep, that's pretty much a lot of calls
Yeah.
with security groups. The other thing that we can do with Lattice that's currently only available for services, so not resources, is be able to add IAM policies. So you can add authentication and authorization on top of Lattice for access to your services. So ultimately, you can create an IAM policy, and that could be a policy that's on the whole service network level. So here's an example of a policy that says, I only want to allow traffic to services as long as the traffic is coming from a principal that's within my organization, and that's organization 1, 2, 3, 4, 5 example. Right. So if traffic comes from my organization, I'm going to allow that traffic. If it's not, it's dropped. You can have a separate layer of policies that usually are more granular, that each service owner can create and specify additional rules. So this time I'm saying, okay, as for service 1, not only you have to be part of my organization, which is applied on the service network level, you also need to come from the example role, and you should be connecting to service 1 and not other service. And then I'm only allowing get, so you can't do posts, you can't do head, you can't do any other HTTP method types. So you can be really granular with your access. The thing to call out here is that if you enable IAM policy on Lattice, you then need to make sure that the client is signing any request by adding a signature v4. It's a AWS signature specific for IAM access. So the client needs to use the credentials to generate that signature v4. So use IAM credentials to generate that signature v4, and then attach it to the request such that Lattice can evaluate it. If it's missing, traffic is going to get dropped. So there is some effort on your end, if you have an application that currently is not doing that, to be able to add this to your application flow. But if you can, then it becomes super powerful, because now you can use IAM to really control access on your applications. Okay.
Oh, by the way, Dominic did confirm that we can configure 169.254/16.
Oh, he already tried it.
So, but does that mean that anything going towards those Lattice endpoints will be routed accordingly to where you want them to be routed in the VPC? I don't think we would bypass the route.
Yeah, I think you would have to put the same route on top, and we would prefer it would have to be same exact route. So it's 169.254.171. It's a /24. I don't know what would happen. I think if it's AP, we open the APIs and you can put whatever you want in there. So if you were to put the same route, you would probably override the behavior and break it. But I don't know who would be putting those routes in, to be honest.
I'm thinking if someone wanted to put a firewall in front of Lattice, I don't know if that's a good idea or not.
So you could probably force a firewall in front of an endpoint, but then the question is, what are you actually getting from adding the firewall other than complexity? You're paying extra, but if that firewall all it's doing is like a ACL on steroids, you're not getting a lot of value really, because all logging you can get on Lattice, you can see what's talking to what, you can get the application layer information from the Lattice logging. So you would have to really think about what is it exactly that your firewall is doing, what is the value that you're getting by trying to wedge it in between your client and Lattice. Because if it's all it's going to be doing is I'm allowing a source IP address to port for free, again, Lattice is doing that out of the box for you. So there's very limited discussions I had. Is there may be something in terms of WAF, where if it's a HTTP application and you want to start inspecting if there's no malicious content inside of the application, there could be something there. But again, for Lattice, it's mostly client like microservices communication. So a lot of the use cases is a service-to-service communication. So you would have to have really one of the services compromised and those services trying to do, I don't know, SQL injection to some backend. So it's it's not really like a random client on the internet connecting to Lattice. Then for that, you would have already a layer of WAF, CloudFront, CDN, whatever. Once you're in, then you're using Lattice to just expose the applications that you need to. You can add IAM to an extra layer of control to make sure the requests are authenticated. But then, yeah, it's a good question, but it would be a good brainstorm to like really figure out, is it adding value or is it just adding complexity and cost?
I think it's a fair comment. And I know we've only got 8 minutes here.
Okay.
TechFueled said that routing was done at an E&I level. I think maybe we'll defer this one for Jamie for next week for the deep dive session,
Yep.
just in the interest of time. But thanks for the question, TechFueled. I
Okay.
think that seems right to me. But yeah, to you, Tom.
So life of a packet, what's going on here? So client does a DNS lookup, and this is a service first. The source IP addresses and ports are in blue, and then in gray at the bottom, we have the destination. So we do a DNS lookup, we get the 169 address, client does a connection. For a service, Lattice will do policy evaluation if you configured IAM, and then the traffic to the destination. So let's say we're going to EKS. The source IP address is going to be that 169 range. So that's where you need to make sure that on EKS, you're allowing 169 range, 169.254 to connect to your application. And then the source port is going to be some Lattice port that Lattice picked. Destination is something on EKS, some IP address of a pod, and then port 443 if it's HTTPS application. From a client IP visibility point of view, Lattice will add additional headers. There's a whole set of headers. So there's an X-forwarded 4 header that will include the real client IP, 10.0.0.20. And then there's a bunch of additional headers. So if you used IAM, the Amazon Lattice identity header is going to pop up with all the information about principal, organization, info that you get from IAM. So that is going to get passed to the backend application. And then Lattice Network and Lattice Target, those are headers that are always added, regardless if you're using IAM or not. There's some additional metadata about the request. So super useful info in there. With resources, it's a different story, right? Because this is a TCP connection. We do a DNS lookup. We send it from our client to 129.224. We hit the resource, and then traffic comes out for the resource gateway and grabs as the source the resource gateway IP address. So whatever site I have in that VPC, the resource gateway is going to need multiple IP addresses from that VPC because it will use a different IP address for different resources coming in, kind of like a one-to-one NAT. And then the destination is the EC2 instance. So we have no IP preservation in that scenario. Everything looks as if it's coming from the resource gateway. Okay. I'm going to move fast. I think we only have 5 minutes left. I want to touch on the multi-account deployment and pricing, and I think we can end on that. let's say we have all of these components. So client, VPC, service network, a service which is up top, and the resource, all of them in different accounts. How do we deal with a cross-account? First of all, access. So we can share services with the account owning the service network. We can share resources with the account owning the service network. And in that share, we can also say, are we okay with the service network that we're sharing to be shared further with another account? And in this example, we will share that service network further. So I'm allowing that as the resource owner, but I can disable that. And then finally, once services and resources are registered, these can be shared with a service network with account A and establish, service network endpoint or association. From a cost point of view, when we're looking at services, the only cost to account for is on the service owner side. There's an hourly element to it, and as well as data processing and a small HTTP request charge. So pretty straightforward if you're just accessing services. From a data volume or data process point of view, it's in US East 1, it's 2.5 cents per gig. So it's very similar to the cost you would have with Transit Gateway or Cloud One. So it might actually, from a data processing point of view, if you're able to bypass Transit Gateway and bypass the load balancer, you might end up better off end-to-end from even a cost point of view on Lattice. The service owner is charged, but and no one else. With resources, it gets a little bit more complicated. The resource owner is going to be charged processing. The service network owner, there's some hourly charges for every resource. And often the owner of the resource is the same entity as the service network owner, but I went for the most complicated example, so it's the easiest to see. And then account A, the owner or the consumer will be charged for the volume. So interesting call out here is that the service network endpoint doesn't have any hourly charges associated with it. Okay, so putting it all together.
Wait, let's go back just for 4 more seconds so people can maybe take a screenshot of the pricing thing. I think this is actually a great reference to come back to at some point. But we can talk more about pricing in the next sessions.
I had other examples of the endpoints. I'm going to skip those. I want to go to the final slide because we have these 2 different models now. We're using service network and using Lattice or using private link, right? So with Lattice, we just saw that you get access to TLS HTTP applications through services and then TCP resources. Private link, which you may have seen used by AWS services, that's one option. So like if you want to privately get to a CloudWatch. With network load balancer, private has been used for to enable interface endpoints. And then you can also access TCP resources using resource endpoints. We didn't have time to go into that, but it's more like a one-to-one basis. So if I have a resource and I don't want to use a service network, I can use a one-to-one basis to connect to a resource endpoint. And then finally, I can use an endpoint to connect to the service network itself. So service network is really the many-to-many connectivity, whereas VPC endpoint is ultimately a one-to-one. So for every resource, if I want to expose that through a resource endpoint, I would have to create a single resource endpoint. But if I'm using a service network, I can have multiple resources connecting to multiple VPCs. It becomes many-to-many. Finally, service network, it's not natively reachable from on-prem. You have to create an endpoint like we saw earlier, the service network endpoint, whereas any VPC endpoints are reachable from on-premise. Okay, and I know we had to rush to the final section and didn't get a chance.
Right on time, Tom.
Really didn't really get a chance to dive into the resource endpoints, but maybe we'll have a little bit of time next time.
Yeah, so next week we'll be coming back with a deep dive on Amazon VPC Lattice use cases. So I think we'll cover a bunch of this stuff again and at more depth, time permitting. So thank everyone for joining this week. I think this has been a great session, Tom. I learned a bunch and looking forward to the next one. Anything you want to say, Tom?
Nope. Thanks, everybody. Okay.